Hello students, this is Gaurav K Sharma and today I am going to teach you physics of class 9 and our first chapter is motion. In order to understand the motion, you must have to understand the second term rest. See, motion and rest are two interrelated terms because you cannot describe any object simply saying that it is motion or it is in rest. So I can prove that the object which you are considering in motion, I will prove it in the rest just after the lesson. So before you understand the term motion, first you will also understand the reference point. What is this reference point? Basically it is a fixed point. What is this? Fixed point. Or you can simply say not movable. First decide the object to which you want to describe that it is in motion or it is in rest. If suppose this is the tree, okay, this is the tree. I know that my drawing is not good, so just consider this as a tree, okay. Now suppose someone, no need to laugh, I know that my drawing is damn good. Suppose someone is sitting beside this tree and distance is 1 meter, okay, means the distance between this tree and this boy is 1 meter, okay. If I come after 30 minutes, I found that with respect to this tree, that now the distance between this tree and the boy is 1 meter. One observation. Next 30 minutes, I visit again and again I found that the distance is again 1 meter between the tree and the boy. Next 30 minutes, I also visit the same position. I found that again the distance between the tree and the boy is 1 meter. What are you noticing that? You are noticing that the distance between the tree and the boy is not changing with time, okay. If a body, here the body is boy, a body does not change its position with respect to a reference point, which is tree here. If a body does not change its position with respect to a reference point, okay, regarding the time, means whatever the time may be, how much the time passes may be, okay. If a body does not change its position with respect to time to a given reference point, it means that body is said to be in rest. Let me conclude. The boy position is not changing with compared to tree. It means that the boy is in rest with respect to tree. Reference point you have to mention. Is that clear? Now this boy is, there is a car or whatever you can say, any vehicle, don't go on my drawing. This is car, it is continuously moving in this direction, and what are you noticing that after not only 30 minutes, if this car is moving, after every minute the position between the tree and the car is definitely will be changing. I am saying that the position between the tree and the moving car is continuously changing. So what are you observing? You are observing that the position with respect to a reference point is continuously changing with respect to time. So you can simply say that the car is in motion. Is that clear? If a body change its position with respect to a reference point with the time, means reference point must be there. In order to explain the, or in order to describe the position of the body, reference point must be there. If with respect to reference point position is changing with the time, so you can say that the body is in motion. If with respect to reference point the position of a body does not change with the time, so it will consider it as a rest, okay. So motion and rest are interrelated terms. There are many types of motions. First is uniform motion. If a body if a body change its distance with regular interval of time. Or I can simply say that if a body travels equal distance in equal interval of time, then it is said to be in uniform motion. Let me repeat. If a body travels equal distance, if a body travel equal distance in equal interval of time, equal distance in equal interval of time, then the motion is called uniform motion. And the second is non-uniform. If a body covers equal distance in unequal interval of time or unequal distance in equal interval of time, then the body is said to be in uniform motion. Let me give you example. If we are moving point from A to B, then C to D or B to C and then C to D, and the distance between A to B is 1 meter, again 1 meter, again 1 meter. To cover from A to B, distance is 1 meter, and if you take 30 minutes, again B to C, again you takes 30 minutes, and C to D again takes 30 minutes. What are you observing? Equal distance in equal interval of time. In first interval, the distance is 1 meter and the time taken is 30 minutes. Now comes on next, from going to B to C. Again you are traveling B to C, that is 1 meter, and again you are taking time 30 minutes. So what is the common? Same distance and same time. So here you are moving in a uniform motion. If it is not so, then simply it is called non-uniform motion. Okay. Now comes to next topic, distance. Distance is the actual path covered by the body. It is not imaginary. Suppose this is the point A and this is the point B. There are so many ways to go from A to B. Like this you can also go. Directly you can also go. Like this you can also go. And like this you can also go. Means there are multiple ways from A to B. Is that clear? In which you are actually traveling. If you are traveling or covering this path, then this is also called distance. If you are covering this path, this is also distance. If you are traveling with this path, this is also called distance. So what is distance? Actual path covered by the body, and its SI unit is meter. Means it is measured in meter. Okay. Now comes to next, displacement. It is the shortest distance. What is shortest distance between two points or two objects? Okay. Here with this example you can see that which is the shortest path between A to B. This could be the shortest path. This is not the shortest. This is also not the shortest. There is only the one possible way to move from A to B if we talking about the shortest path. So AB can be called displacement. So what you are observing, distance can be many, but displacement will be only one, and its SI unit is also meter. Okay.